What's good, Year 1005 mathematicians? Mr. Herman here, and this lesson we'll be looking at Lesson 4, Exercise 9C, which is taken straight from the Year 10 textbook. And we're going to be looking at measures of spread. The previous video we looked at measures of center, so mean, median, and mode. This will be looking at the spread of data. And what we mean by the term spread is we're talking about data sets that have a wide sense of variability. Okay, so sometimes we can have a set of data that when we look at it, the lowest and the highest number could either be really spread apart, so it has a big set of variability, or it can be really small. The lowest and highest number can be really close together, and that has a low sense of variability. And looking and exploring this type of characteristic within data can give us some insight to talk about what's going on behind the scenes, and then make better judgments or generalizations on the data itself. But before we get to that generalization parts, and before we can make conclusions, we have to look at different types of what we call five-figure summary and the measures of spread. Now, there's going to be a lot of information within this, so I'm most likely going to break this video up into two parts. So, five-figure summary, all that means is when we get our data set and we order it, we put it in order from smallest to largest, we can extract these five different sets of information. Every single data set will have it, assuming that the data set is more than, I think, 6 or 7 data points. The first thing is the minimum value. This is really easy. When you order it from smallest to largest, it's the smallest value. The lower quartile, which is also known as Q1. The key word in here is quart. And when you think of quart from quartile, you think of quarter. Okay? You think of quarter. And the number above 25% of the ordered data. So if I had ordered data and I keep going from the start and I stop at the 25th percentage part, or 1/4 from the start, whatever that number is would be considered as the lower quartile. Sometimes you can get two numbers, which we'll see in our scenarios. That will be our Q1. The median, or Q2, so the second quarter, also known as the half, this is the middle value above 50% of the order data. Again, median is just the middle value. The upper quartile is like the opposite of Q1. It's the Q3, which is above 75% of the ordered number, or ordered data, sorry. And then the maximum value, which is obviously the last value. So how I think of it is, just pretend that this rectangle is a data set, and we've had numbers ordered from smallest to largest within that rectangle. Our minimum is here, our maximum is here, Q2 or median is here position wise, our Q1 and our Q3 is here. Okay, doesn't really necessarily matter what type of numbers in here, as long as they are ordered from smallest to largest, we can find the positions of this here. Okay, and once we get these values, once we find what these values are, we can work out the actual measure of the spread. And there are two important measures. The first one, and the easiest one, is the range. And the range is just taking the max value and you're subtracting it from the minimum value. So for instance, if I had some data set where the minimum value was 2 and the maximum value was 11, in this case my range would be 9, because my numbers range from 2 to 11, so there's a difference of 9 here. The higher the range number, the more variability there is within the whole data set, but the lower the range, the closer these numbers are. Okay, and it's good to get that insight, that information. The second thing is the interquartile range, or IQR for short. And the IQR is just getting the upper quartile, or Q3, and subtracting Q1. So the normal range was finding the difference between the lowest and the highest. The interquartile range, and you can hear it within the title, interquartile, inter just inside, quarter and range. So it's just this inside range. So maybe I have a data set here where the Q1 is 4 and the Q3 is 8. In this case, our interquartile range is 4. Okay, just the middle chunk and the middle range. Now, why we would want to work out what the interquartile range is really depends on what type of data set we have, and it also has to do with a fact called outliers, which we're going to see in the next part. But all this means is, say for instance, I wanted to know the range of this data set, but instead of 11, I might have 95. Okay, the minimum Q1, median, whatever that could be, and the Q3 are still the same, but the maximum is going to be 95. And then I ask you, hey, what's the range? And you say, the range is 93 in this case. That range is not really a true depiction of most of the data that is here. So as a safe bet, we'd rather try to find what the interquartile range is, so that way we know, okay, so our interquartile range is 4, so the middle chunk range, or 50% of this data, 25% here and 25% here, is 4, and that's a safer bet, okay? That is assuming we do have these things called outliers, which we can try to work out within the next part. For now, I'm going to show you how to find your medians and your Q1s and your Q3s, depending on what type of scenario you are in, okay? Okay, having a look at these 4 different examples on the side here, we have got 4 scenarios and they've been split up into 2 different parts. Whether we have an odd number of data points, or whether we have an even number of data points. So the first 2 scenarios with an odd number of data points, if we do a survey, we get our data points, which is numerical, and we count them all up, and the amount that we have, our n value, so n being just the amount of number of data points, is odd, we get put into a scenario where we can extract the middle number, or Q2. Okay, when we have an odd amount, it's very easy to get the middle value. Okay, so in this case here, this scenario 1 is when we have an odd number of data points with even sides. What does that mean? So let's first get our Q2. All right, this is our Q2, and we know that Q2 is equal to 4. Remember, we order it from smallest to largest, and we find our middle number. In this case, is 4. The next thing we want to do is we want to try to find where our Q1 and our Q3 lies. It's easy to find the smallest and the largest, that's 1 and 7. But more importantly, I want to look for the Q1 and the Q3. So in this case here, when you look at the 2 sides, the first thing we're going to do is, if we have an odd amount of numbers, we are going to forget about that 4 for now when trying to find our Q1 and Q3. So we say we omit it, we forget about it, we just disregard it for now. On this side, we have 4 data sets or data points, and on the right hand side, we have 4. This even sides, that's what that means. There's an even amount on both of these sides. And the reason why this is a factor in trying to find Q1 and Q3 is that it's actually tricky to find the middle of this side, because there's actually 2 numbers. These 2 here, and then same on the other side, these 2 here. So to compensate for that, and I'm assuming that you've worked on this when trying to find the median in other scenarios, between 1 and 2, this Q1 is equal to 1.5, and this Q3 is equal to 6.5. Okay, so we've got our Q1, we've got our Q2, and we've got our Q3, meaning our IQR is this 6.5, take away 1.5, and in this case 6.5 take away 1.5 is going to be 5. So our middle range, or IQR, into a quartile range is 5, okay? The second scenario looks at, again, if we have an odd amount of values. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 is odd. We can take the middle value. So our Q1 in this case is 7. Again, ordered from smallest to largest. But this time, the side amount is odd. 1, 2, 3, 4, 5 on this side. And that's an odd amount, and 1, 2, 3, 4, 5 on this side, which is another odd amount. And because these sides are odd, this scenario is actually quite simple because we don't have to find two middle numbers. We're actually just finding one middle number. 1, 2, 3, 4, 5, middle number. 1, 2, 3, 4, 5, middle number. So we don't have to work out an average of some sort or split two numbers in half to find the middle value. In this case, our Q1 is just a straightforward 3, and our Q3 is just a straightforward 9. So in this case, our IQR is 9 take 3, which is 6. So, odd number of data points. When n is odd, you get two scenarios, even sides and odd sides. Same thing happens when we have an even number of data points, but there's this little consideration you have to take when we have an even number of data points. Again, we have even and odd sides. The only tricky thing in this part is that when we have an even amount, we split this line, we put this line in the middle, and we work out our Q2, in this case, is just the average of 5 and 7, or what's in the middle of 5 and 7. So our Q2 in this case is 6. Now, again, we've got these even sides on both sides here and here, 4 and 4. We find the two middles. And the really important thing is these two middle values here, you don't forget about them. You actually include it. The left value you include in the left side, and the right value you include in the right side. In the previous example, when we had just one middle number, we forgot about it, okay? And that was just a choice statisticians made, to just forget about it. They could have included it in both sides if they wanted to, but it was just easier just to forget about it and consider what's on the left of it and what's on the right of it. But in the case where we have an even amount of data points all up, we split it in the middle and include this value for the left and this value for the right. So in this case, our Q3 is in the middle of 9 and 9, well that's just 9. And our Q1 is in the middle of 2 and 4, which is 3. Our entire quartile range is 9 take 3, just like the previous example, which is 6. And the last scenario before we finish up part 1 of this video is looking at the odd amount on each side. So a Q2, sorry, is the middle value in between 6 and 7. So our Q2 is 6.5. Now in this case here, our Q1, 1, 2, 3, 4, 5, because there are 5 data sets, we just got to extract one middle number. Not 2 in this case, just one middle number. I might put that in red just to make it consistent. And again, 1, 2, 3, 4, 5, middle number 9 here. So right here, Q1 is equal to 4, and here Q3 is equal to 9. Our IQR is equal to 9 take 4, which is 5. So that concludes part 1 of getting measures of spread. what we looked at was finding these 5 different important numbers, which is called the 5-figure summary. You got to make sure that you order it from smallest to largest. And then we looked at how to find the range in the Intel Quartile range based on these Q1, Q2, and Q3 numbers, and obviously the minimum and the maximum value. The next video is going to be looking at outliers and what outliers are and how to work out an outlier within a data set. Make sure you tune in to the next video, part 2. See you guys then.